Hi, welcome you all for the fundamentals of embedded system. In the fundamentals of embedded system, we are going to see introduction to embedded system. Inside this topic, we are going to cover what is an embedded system versus PC system, then some of the real world example of embedded system which is around us. Then we can see simple block diagram of embedded system, then how software and hardware interaction is happening inside the embedded system and how it is important. First, we can see what is an embedded system. Embedded system is nothing but it is a small computer which is built inside a device, and it is intended to perform some specific task. I mean, embedded system is nothing but they are saying it is similar like a small computer, but it is built inside a device to perform some specific task. So we can say embedded system is a combination of both hardware and software, as well as it is designed to do some particular task alone. For an example, washing machine will be used to washing the cloth. AC will be used to regulate the room temperature. Similarly, in most of the case, embedded system does not require the user interaction. It works automatically. Rarely it requires minimal interaction of users. So they have given a simple definition. Embedded system is a computer system designed to perform dedicated tasks within a larger device. And here they have taken two examples: washing machine and a microwave oven. Washing machine is an embedded system which controls the water level, washing time, and spinning. Everything is controlled inside the washing machine. Similarly, microwave oven is also an embedded system where it controls the temperature and timer. Next is difference between embedded system. I mean, how the embedded system and PC systems are differentiated. Here I have differentiated using some of the feature, like which purpose it is used, how about the size, how will be the user interaction, and how about the software which we used in embedded system and PC system. Then cost, how will be the cost, whether the embedded system is high or the PC is high. Everything is given as a future. Depending upon the future, we are classifying this embedded system as well as the PC system. So purpose is, first we can see embedded system is specifically designed for specific task only. It won't do multiple tasks. If you go for PC system, it will use it to do multiple tasks. Simultaneously, I can do all the tasks. Multiple tasks it can handle. We can go with the next feature, which is size. Embedded system is small when compared to PC system. Then user interface. In previous slide itself, we have discussed it does not require the user interaction, but in some cases it may require limited or minimal number of interaction. If you take PC, if I require some output, obviously I have to give some input to the PC, then only it will do the process and produce the output. So it continuously requires user interface. Then we can go for software. Embedded system will comes with a fixed program. We are not going to update it periodically. But if you take PC system, many applications are required, as well as if I want new application, I will flash or I will update the application periodically. Cost wise, embedded system is low when compared to PC system. And example is washing machine is an example. Here desktop or laptop is an example. Next, these are the real world examples of embedded system which is present around us. First one is TV. TV, by using a remote, we are controlling this TV, isn't it? We can able to change the channel. I can able to change the display quality as well as sound. So inside the TV, there is an embedded system. So only we can control everything. Similarly, digital camera is also an example of embedded system. In digital camera, we are we are capturing the image. Not only we are capturing the image, we are storing those image inside the storage which is present inside the digital camera. As well as if I want to view the image also, we can able to view. So everything is done because inside we are having one controller that is coded that is coded in order to perform all the tasks. Next one is car ECU is also an example of embedded system. Lot of sensors will be available inside a car. If some sensor is behaving differently, or if suppose the sensor crosses the threshold, so those information will be indicated in our dashboard. So everything is happening because we are having a small embedded system inside each sensors, and they will be interconnected. Then router is also an example of embedded system. Then this is a simple block diagram of embedded system. Mainly the embedded system will consist of processor unit, then we have input unit and output unit. If you see here, this microprocessor or microcontroller is the central part of the embedded system, or else we can say this is the brain of the embedded system. Okay, if I am having microcontroller or microprocessor, then obviously I require some memory because it has to store the data or do some processing, means it requires some memory, as well as it requires power supply, right? We can use DC power supply or some other batteries I can use. That depends upon the application where the embedded system is used. Then this particular part is right. This is called input unit and this part is called output unit. Okay, here, for an example, we can have a real world example. In this place, I am having a temperature sensor, for an example, and here I am having a LCD display. So what I am doing is, I am just using the temperature sensor, measuring the temperature, and sending the data to microprocessor. From the microprocessor, the temperature will be displayed in my LCD display. Okay, this is happening. So obviously, sensor is my input part and actuator is my output part. So this is clear. Then why do I require this analog to digital converter and digital to analog converter? Mostly our microcontroller will do process with the digital signal alone. If suppose I am using analog sensor, means the output which is coming from the sensor will be in analog form. But if I give the analog signal to the microcontroller, it won't process that. At the time we are required to convert the analog signal into the digital signal. That's what we are using the analog to digital converter. Similarly, it is applicable here. For an example, my LCD display will work only with the analog signal, means the signal which is coming out from my microcontroller will be in digital form, right? So we are supposed to convert the digital signal into analog signal, then only it will be displayed in the actuator. So I hope now this block diagram is clear for you, isn't it? Next we can have a simple example block diagram for embedded system. Here I am having three input device: humidity sensor, soil moisture, temperature sensor, and here we are having LCD display, fan control relay and fogger control relay. So these are the input part and these are the output part. This is a simple example of automatic greenhouse system. Next we are going to see about hardware software interaction. In embedded system, the device works because hardware and software cooperates with each other. For an example, how they are differentiating embedded system hardware and software. The physical part which are called software, physical part which is called as hardware. Physical part in the sense microcontroller, sensor, LED, motors, memory, everything comes into the hardware part. But some logic has to be required, right? What it has to do, when it has to do, how it has to control the LED, everything will come under the program part, and we can say it is in software. For an example, I have the hardware part, but I don't have software inside my microcontroller, means it is totally wasted. Similarly, in software, I am having the software part, but I don't have the hardware part, means it is also useless. So, if you want a complete embedded system, we must require both the hardware part and software part. Here is an example how we can separate hardware part and the software part. Here it is an automatic room light system. They are saying a motion sensor, a microcontroller, light, everything comes under the hardware part, and some logic is there. According to that, my microcontroller will guide the light as well as the motion sensor, right? That logic is called software logic. Like if my sensor detects any motion, it sends the signal to the microcontroller, and my microcontroller will control the LED depending upon the input that it gets from the motion sensor. Okay, so this logics comes into the software part. So now it's your time. You can consider a temperature control system and think what are the hardware parts are required for the system and which logic comes into the software part. Okay, I hope this session is useful for you. We can meet in the next session. Thank you.